In 3.2, we're going to talk about the slope of a line. So the slope of a line is basically how steep is the line. So you could have like a really steep line, that's not very steep, or you could have a flatter line. If you think about the pitch on a roof for a house, you've seen houses that have really steep, it's called the pitch, but a really steep roof, and some around here, there's some that are really flat. And that's the slope of that line that's making the roof line. So you can have slopes that are, large and go up quickly, or not as large and go more flat. You can also have, we would say those two lines that I have drawn, we'd say that they are increasing because as you move from left to right, it's going up higher. Okay, so, but you can also have a decreasing line like that, and that's determined with the slope as well. Okay, so a lot of times we'll say the slope it's a ratio for a line. It's the ratio of the rise over the run. So you may have heard that before. And what we're talking about is it's how much up you go to how much over you go. And it has to be consistent. That ratio has to be consistent or you don't get a straight line. So for our lines, we're graphing linear equations, and they graph to be straight lines, we say, and so that rise over run, or that slope, is consistent, okay? We also indicate slope with m. Usually that's the variable we use for slope. Think m for mountain, I guess. Okay, so they have an example here where we're just getting started with slope and the idea. So it says find the slope of the line, and they've given us a picture. So what you want to do is you want to look for 2 points that you know on the line. So it looks like this point right here, and I'm talking about like I don't have to guess if it's a third or a half or something. So I'm looking for something where it's on the grids. So I kind of know the coordinates for that point there. And then it looks like I know that point right there. So maybe I should draw them in a different color so you can see them better. So that point and that point. And what we're going to do is we're going to go from one point to the other. So we'll do the the rise first. Now, it doesn't really matter which point. In fact, maybe I'll do it twice. Let's say I start with the point 0, 1. I actually am not going to rise. I'm not going to go down. And I'm trying to get to that other point that I know. So I'm going down 1, 2, 3. So it would be a down, so -3. And then how much do I run? So how much am I moving to the right? Well, I stay there and I count 1, 2, 3, 4, 5. And so it would be -3 over 5. We'd say that was the slope. Okay? So my slope for this line, it looks to be -3 over 5. Now, I think we talked about the negative sign, but remember you can put it out front, or you can put it in the numerator, or you can put it in the denominator. Usually we either put it out to the side or in the numerator. Now, what if you wanted to go the other way? What if you wanted to start from this point here, and count up 1, 2, 3. So you count up 3, and then to the left, 1, 2, 3, 4, 5. But because it's to the left, it'd be -5, so it'd look like that. And it's the same value, right? So you're still getting the slope, m equals -3 over 5. Okay? So that would be the slope of this line. And like I said, it has to be consistent. So you could go from any other 2 points and also have a ratio of -3 over 5. We didn't pick other points because we were looking for points where we actually knew what the coordinates were, where they were on the grid. So if you're having to count it out, I would suggest doing that. Look for actual points that are integers. Okay? It'll be easier.